Okay, now we will move on to planar defect free surface. So, what is planar defect free surface? So, it is a planar defect where at the external boundary of a crystal, where atoms have broken bonds and higher energy. So, it is the most obvious boundaries along which the crystal structure terminates. So, now I will explain more detail. So as we can see at the image above, this diagram illustrates a free surface, also known as an external surface, which is a type of planar defect in crystalline materials. So inside the crystals, atoms are arranged in a regular lattice and are fully bonded to their neighboring atoms. We can see that they have four neighboring atoms in each. However, at the free surface, which is the red line in the image above, the crystal lattice end. So the surface atom have fewer neighboring atom. Because of this, some atomic bonds become broken or unsatisfied, as shown by the marks near the surface in the diagram. So these broken bonds cause the surface to have higher energy, which is called surface energy per unit area. Due to this high surface energy, free surface are more reactive and are often where corrosion, cracks, and metals begin to occur, be, become to occur. So at the image below, I will demonstrate how how it works. So at the left side, we can s- we can see the perfect crystal lattice. So if I cut into two at the right side, we can see a free surface uh, where the atoms neighboring atoms end, and we can see the free surface there. Okay. Okay. So now I will explain the example of the free surface, planar defect free surface. Yeah. So example number one, ortho surface of metal rods, and number two, surface of ceramic or polymer, and number three, thin films and nanoparticles. That's all.
This planar defect, which is a twin boundary. So what a twin boundary truly is. A twin boundary is not just a mirror, it is very special, perfectly coordinate rearrangement of atoms. Imagine atoms arranged in layer. In a normal boundary like grain boundary, the arrangement on both sides is random or misaligned. But in the twin boundary, the atoms follow a strict rule. One part of the crystal is rotated or reflected relative to the other. The reflection is exact, like flipping one side of a crystal over a plane. This perfect organization is why the twin boundary is considered a low energy defect. Think of it like this. Grain boundary is like messy transition, like ripped paper edges. Twin boundary is like clean mirror, like folding paper neatly. Twin boundaries are therefore not harmful defects, they actually improve properties. So why do atoms form this mirror pattern? Atoms are always trying to find the lowest energy, most stable arrangement. Under some conditions, atoms cannot slip normally, like in usual plastic deformation. So instead of moving in many directions, they move in a very coordinate pattern, altogether forming mirror symmetry. This coordinated motion is called twinning. So this material deformed mainly by two things, which is first slip, is dislocations move and layers slide. The second is twinning, which is a block of atoms rotates or flips into a new orientation. Slip is easy in most metals. Twinning is harder and happens only when slip is difficult. For example, like HCP metals like magnesium. Temperature is low, applied stress is very high, and loading is very fast. Twinning provides the material and escape mechanism to prevent cracking. So there are two types of twins, which is growth twins and deformation twins. Growth twins